Hi friends, this video we are going to find eigenvalue and the corresponding eigenvector of the 2 by 2 matrix. Now we start with this is our problem. Let A equal to 3 minus 4, 2 minus 6. Find the all eigenvalues and the corresponding eigenvectors. So first we want to find what is the characteristic equation. The characteristic equation is P of lambda. This is equal to determinant of A minus lambda I. Is them our characteristic equations. So or we can use the formula of E of lambda equal to, so it's a 2 by 2 matrix, so lambda square minus trace, that is 3 minus 6, that is minus 3, so plus 3 lambda plus determinant of the matrix, that is minus 18 plus 8, it's become 10, minus 10 will come. So this 3 is from the trace of the matrix, this is from determinant. The formula is, we already posted a video, our earlier video, that is our P of lambda is lambda power n minus S1 lambda power n minus 1 plus S2 lambda power n minus 2 and so on, plus minus 1 whole to the power n Sn. Here Si is the sum of the principal, minor of order I. Okay, so it is a 2 by 2 matrix, that is why lambda square. S1 is the principal, minor, that is 3, and minus 6, that is if that we call it a trace. Then here is a 2 by 2 is minor matrix, that's a whole matrix, the determinant is minus 10. This way only we find the characteristic equation. Now I want to find the, what is the eigenvalue? Eigenvalue is roots of the characteristic equation. So that is P of lambda equal to 0. So that is, this implies lambda square plus 3 lambda minus 10 equal to 0. This is nothing but lambda minus 5, lambda plus 5 times lambda minus 2 equal to 0. This implies lambda equal to minus 5, 2. These are the eigenvalue. Thus, eigenvalues of the matrix A are -5, 2. These are the eigenvalues. So our next aim is I want to find the corresponding eigenvector. So that is lambda equal to -5. How I can find? Eigenvector is A minus lambda I times x equal to 0. This is our eigenvector corresponding to lambda. So lambda equal to -5. So this implies A minus 5. A minus it become plus 5i times x equal to 0. Now you take it, this is as b. So bx equal to 0, where b is a plus 5i. So this so b equal to, we know that 3 plus 5 is 8 minus 4, 2 minus 1. This is our b. X is x1, x2 equal to 0, 0. Okay, now I want to solve this one. What is the meaning? This implies we are going to the null space of B. B is the eigenvector of A. A corresponding eigenvalue lambda equal to -5. So this is the matrix. So first of all I want to how I can find the null space of the matrix. First we can convert to the row reduced echelon form. So that is our B equal to 8 minus 4, 2 minus 1. This is equivalent to, because I want to take the pivot element must be 1. So 1 minus 1 over 2, 2 minus 1. So I will choose, this is my pivot element, correct? So pivot element means this case must be 0. How we can convert? Here R1 is simply R1 divided by 8. Second things, I want to take this guy as 0. So first row I didn't disturb. I don't want to disturb anything. So R2 is R2 minus 2 times R1. This become 2 minus 2 is 0. Minus 1 plus 1 is 0. So this guy also 0. So I have the only one pivot person only. So this implies you take it, this is you taken as a U1. So null space of equal to null space of B. So this implies 1 minus 1 by 2, 0, 0 times x1, x2 equal to 0, 0. So x1 minus x2 equal to 0 divided by 2. Then, so now I can write the vector form is I required x1, x2. So here x1 is the basic variable, x2 is the free variable. So this guy I can write as x2. This implies we know that x1 equal to x2 divided by 2, but x2 equal to x2. So 1. Here is 1 by 2. So this is the eigenvector 1 by 2. Is the eigenvector for lambda equal to minus 5. So now I have the another eigenvalue will be there. The another value is lambda equal to 2. So lambda equal to 2. So a minus 2i times x equal to 0. So a minus 2i is 1 minus 4, 2 minus 8. Like our previous step. So now you consider this is some C. Okay, I want to find the eigenvector is the null space of matrix C. So how I can find the null space? So C equal to, write 1 minus 4, 2 minus 8. So this is the pivot position, that is already 1. So I can write as it is 1 minus 4. I want to make this guy as 0. How I can make R2 becomes R2 minus 2 times R1. This guy is 0. This is guy also 0. So now you consider this matrix is some U2 matrix. So null space of C equal to null space of U2. So this implies 1 minus 4, 0, 0 times x1, x2 equal to 0, 0. Clearly here also x1 is the basic variable. X1 is the basic variable. X2 is the free variable. The reason is this is the pivot position. This is not pivot position, correct? That's why. So this implies x1 equal to 4 times x2. x2 is simply x2. I can write the vector form x1, x2 is x2 times 4, 1. So this is the eigenvector. So thus 4, 1 is the eigenvector of A for lambda equal to 2. Okay, so thus, so we conclude A has two distinct eigenvalues lambda equal to -5, 2. The corresponding eigenvectors are corresponding eigenvectors are 1/2, 1, comma 4, 1 respectively. I hope you understand how to find the eigenvalue and eigenvector of 2/2 matrix. Thank you for watching this video.